Hello students, welcome to mathematics class. Students, this is introduction part, that is part 1 of the chapter surface areas and volumes. This is 13th chapter as per your textbook, and it will be the second chapter in the unit mensuration. As a continuation of the unit mensuration, after learning Heron's formula, we are going to learn this chapter surface areas and volumes. In this part 1, we will be learning introduction portion of this, and later we will go for revisiting surface area, volume of a cuboid as well as cube. Okay. Now coming to the meaning of plane figures. The figures which can be drawn on a piece of paper, that is, which lie on a plane, are called plane figures. So figures which are drawn on a paper which lie on a plane are called plane figures. Now example for plane figures: circle, square, rectangle, triangle, parallelogram. They are all examples. Now another important thing, after learning finding area, perimeter of a square, rectangle, triangle, parallelogram, trapezium and circles, we moved on to learn solid figures, finding surface area, volume of solid figures. Which are the solid figures? Solid figures, nothing but three-dimensional shapes which occupy some space, are called solid figures. Next, example for solid cubes. So example for solid figures will be cubes and cuboids, spheres, cone, etc. Now, what is the meaning of volume? See, the space occupied by that solid shape gives us the capacity of it, which we call it as volume. So the space occupied by any solid shape is called its volume or capacity. Now the unit of volume is, unit of the volume cube is cubic units. Means when we cube that units, what we get will be the unit cube. Okay, or it is it is also written as cubic units. For example, if it is units are centimeters, then centimeter cube will be the volume or cubic centimeter. If it is meter, meter cube or cubic meter, likewise. Now surface area. Surface area of all the faces in a solid shape will be the total surface area of that figure. So area of all the faces, when we total them up or add them up, we will get total surface area. In short, total surface area is written as TSA, total surface area. The sum of all the area of faces in that solid shape will give TSA. Unit of surface area is square units or unit square. It is written either square units, we in short write square units or unit square. For example, units are centimeter, then centimeter square or square centimeter. If units are meters, meter square or square meters, likewise. Then Another important thing what even we learned in class 8 was lateral surface area or curved surface area. Lateral surface area is in short written as LSA or curved surface area CSA. Where there will be curved surface area, it will be there for sphere. Why? Because all the side walls are curved. It will be there in a cylinder. It will be there in a cone. It will be there for a hemisphere. So we have curved surface area where the curving or curved nature you could see to the side walls of that solid shape will be called as CSA. Otherwise we call it as LSA. LS will be there for cuboid, cube, okay, and any tetrahedrons. Okay, you have learned them in class 8. Okay, now let me wipe out this. Here you know, in short, lateral surface area is called LSA and curved surface area is called CSA. And what is the meaning of CSA or lateral surface area? The surface area of the solid shape after leaving top and bottom faces, rest all the faces are called lateral surfaces, and area of those lateral surfaces will be called lateral surface area. Sum of lateral surfaces area is called lateral surface area. Which are the lateral surfaces? Except top and bottom are called lateral surfaces. Now unit of the lateral surface area is also same unit square and square units. We can either of that we can use. Then see children, in class 8 when any cuboid is cut out and spread, it looks like this net. Okay, this looks like this net. You have seen the net. Here a paste box which is of cuboid shape is cut out and spread like this, which gave a net of cuboid. How many surfaces are there in this net? You could see 1, 2, 3, 4, 5, 6. 6 surfaces are there. Leaving top and bottom, we have got 4 lateral surfaces. Okay, 1, 3, 4 and 5 are lateral surface. Second and 6th are the top and bottom. Now you know how to find the area of each face. Well, because it's a rectangle shape. Okay, so cuboid will have its length, breadth and height. If I have them, I can find surface area of each of this surface and sum it up will give total surface area, and sum of only lateral surfaces will give lateral surface area. Okay, so the same case is with the even cube which is cut and spread across, spreader like this will give a net of cube. It also has got 6 surfaces where each surface is of the shape square. Okay, if I consider the edge of a cube as A units, then I have side of each square being A and area of each square being A square, and from this I can say easily total surface area as 6 times of the area of one square, and lateral surface area is just nothing but area of only these lateral surfaces which are leaving top and bottom. So leaving top and bottom, these 4 lateral surfaces, if I sum it up, area of lateral surface here will come as 4A square. Okay. In the case of in this cuboid, you know how to find area of each surface. Here in the area of first surface is with L and H as dimension LH, the second one with L and B as dimension LB, third with B and H as dimensions BH, fourth with L and H as dimension LH again, and fifth with B and H as dimension BH, and sixth with L and B as dimension LB. Now I have got LB for twice, where first and sixth surface have got, okay, area of 1 and 6 surface is 2 times LB, area of second, sorry, this is not first, second and fifth, sixth, and first and fourth being 2 times LH, area of third and fifth being 2 times BH. So TSA, total surface area, is sum of all this. If I add and take 2 common, I have got LB BH plus HL being the total surface area, and lateral surface area is the only 1, 3rd, 4th and 5th. So 2 LH added to 2 BH, here 2 is common, H is also common. Let me write in the last that H 2 times of L plus B into H will give area of the lateral surface area. Lateral surface area is 2 times of L plus B into H. See children, the same thing you have learnt in class 8th as perimeter of the base, into height will give lateral surface area. We have learned this important formula. Perimeter of the base into height will give the lateral surface area of any cuboid, okay, or cuboid, or you can say any prism, okay, any prisms, lateral surface area is perimeter of the base into height, okay. This, if you could remember, you will find easily. 2 times of L plus B is the area of the rectangular base, perimeter of the rectangular base with L as dimension, B as dimension, okay. So that's how this is learnt. So we have already learned this in class 8, we will be revisiting it. You know, a cuboid is a 3-dimensional shape. The cuboid is made up of made from the 6 rectangular faces which are placed at right angles. This is the shape of a cuboid, and the total surface area of a cuboid is equal to the sum of the areas of all its 6 rectangular faces. Here you could see a line segment drawn from one corner of the cuboid to the opposite corner. It is called a diagonal of a cuboid. How to find the length of the diagonal? That is an important question in class 9th. Okay. Length of the diagonal is root under L square plus B square plus H square, where L is length, B is breadth and H is height of the cuboid. How this formula has come? Length of the diagonal of a cuboid. Let me explain you here taking this. See children, this is a cuboid and here is the diagonal. How can I find the length of this diagonal? I can find by using diagonal of the base. You know diagonal of the base. Why I have to take diagonal of the base? It is just because diagonal of the base shape, here let us say base shape is of L, length, B, breadth, where from here to here is B, from here to here is L. Now with the base height, this height is forming a right angle, and this right angle with the height, this base diagonal and the diagonal of the cuboid form a right angle triangle. Height h, this is a base diagonal. Okay, so diagonal of the base. How to find the diagonal of the base? How to find the diagonal of the base? It is again Pythagoras theorem. So diagonal of the base with length and breadth form a right angled triangle. That means you know how to find here L square plus B square under root will give you diagonal of the base. Let us say diagonal of the base is A. Okay, and A is equals to root under L square plus B square. Now let us say diagonal of this cuboid is capital D. Again it is forming by Pythagoras theorem only. By Pythagoras theorem, D is root under A square plus H square. A square plus H square, because Pythagoras theorem says hypotenuse square is the sum of the square of other two perpendicular legs. So I took directly square root of, because I want only the diagonal. Now you know A is this, A square will be L square plus B square. I'll straight away submit that. Substitute there L square plus B square plus H square under root will be the diagonal of the cuboid. Okay, so diagonal of the cuboid is root under L square plus B square plus H square. That's how this is derived. Okay, now moving on to the, here is a cuboid I have taken and I have drawn a one diagonal. Okay, joining one of the corner to its opposite corners. You know there are 8 corners, right? I have A, B, C, D, E, F, G, H. So HB is one diagonal I have drawn. Another diagonal, EC is second diagonal. DF is third diagonal. GA is fourth diagonal. Now can you tell me this answer? How many diagonals that cuboid can have? For a cuboid we can draw 4 diagonals. And what is the specialty of these 4 diagonals? All 4 diagonals will pass through one and only one point. It is called centroid of cuboid. Okay, centroid of the cuboid is very, very important. Centroid of the cuboid is the fulcrum where entire mass of the cuboid is concentrated. Okay, like center of a circle we have got centroid of a triangle we have, and centroid of cuboid is here. Okay, it's in the center where we have to visualize it. Okay, the point of concurrency of diagonals of a cuboid will give centroid. Okay, now moving on to the another important topic here. lateral surface area of a cuboid. What is the meaning of lateral surface area of cuboid? Lateral surface area is the area of all the sides apart from the top and bottom faces. The LSA of a cuboid is found area of face AEHD and area of face BFGC in the previous one. I am talking in the previous what I have in this one. Okay. So area of four surfaces, as I have already proved in this figure, A, B, C, D and E, F, G, H will be the top and bottom. Apart from them, rest of the things A, E, H, D, this one, next B, F, C, G or B, F, G, C is second one, lateral surface, and A, B, F, E, front face, okay, front face, and back face D, H, G, C, back face. Sum of their areas will be LSA of cuboid will be 2 times of L plus B into H. Now total surface area we have already seen. It is 2 times of LB plus BH plus LH. Now comes to the volume of a cuboid. How to find the volume of a cuboid? See children, your notebook or a textbook. The textbook, if you take, it is a cuboid in shape, but how that cuboid is formed? Is it is just formed without the papers? No, it is formed when you keep papers one over the other, each paper keeping one over the other piled up, the accumulation of that papers is giving a cuboid. Remember, it is the sum of the areas of all the papers, correct? So let's say area of each paper is LB. I am adding it for once, twice, thrice, 4 times, 5 times and so on. Let's say you have got 285 pages. 285 times I have added. If I added for 285 times LB, can I take that LB common? If I take LB common, what will be the number comes? 1 plus 1 plus 1 plus 1 plus so on. So how many times it comes? 285 times I am adding that LB. That means LB is multiplied by 285 pages. What is this 285 page? It only gives the height. If I think each paper is of 1 mm, that means 285 mm. 285 mm is just nothing but 28.5 centimeter, which gives the height. So that's how the volume comes. Okay. So volume of a cuboid is the product of its all 3 dimensions, that is LB, area of a base, multiplied for H times. Okay, that's how the formula also has come. Volume of any prism is area of the base multiplied by its corresponding height. So area of the base into height will give you this volume. Now let us go for solving some example on these concepts. 1. What is the surface area of a cereal box whose length, breadth and height given as 20 centimeter, 8 centimeter and 30 centimeter respectively? Now if you want to find surface area of this box, it's a cuboid shape, and you know here we will use L 20 centimeter, B 8 centimeter, C 30 centimeter. Total surface area formula is 2 times of LB plus BH plus LH. In that, substituting them, 2 into 20 plus 8, 20 into 8 plus 8 into 30 plus 20 into 30. The product of them, 2 times of 160 plus 240 plus 600, and sum of them is 2 into 1000. We have got 2000 centimeter square being the surface area. Okay. Now I'll wind up this today's session with the example and discussion on cuboid. Tomorrow we'll go for learning about cube and all the details about cube and some examples on the cube. Till then, take care of yourself. Jai Hind. Thank you.